All right, so today we're talking about linearity. So if things are a straight line, and then also continuity, are they continuous or are they kind of like choppy? And so the first thing would be a linear equation or a linear function, okay, is when you graph it, it makes a straight line. Okay. And you definitely have graphed lines, last year. And so you know that if you graph a line, has a y-intercept and it has a constant slope. And so it has a constant rate of change or slope. Okay. And that's the change in y over the change in x. Certainly you've seen slope, but we are going to calculate the slope between some points and see, is it linear or is it not? We can look at the picture too, but we can also calculate the slope. The next thing is you can write a linear equation, okay? And that can show the relationship between x and y. We aren't going to write linear equations today, but you could write an equation, and that's how you graph things. And then also, if it's not a straight line, it's going to be a nonlinear function. Okay, and then if your points are not connected, it's called discrete. Okay. And the domain is a bunch of x values. The range is a bunch of y coordinates. Okay, so you could list them out. And we've done that before to be like, okay, what is your domain? And we can just list out the x values, -4, -1, and just list those out. And then the y coordinates would be the respective y values of each point. Now on this one, if this is continuous, it means you can draw the whole graph without picking up your pencil. Okay, so you would start here and you could go forever to draw your graph. Um, and the domain, you would not want to list those out because there's infinitely many points on this graph. And so you could say it's basically the smallest number you could do is negative infinity, and the biggest number is positive infinity. Or you could call it all the real numbers um, are the graph. And so the domain is the x coordinates on the graph. The y values or the range values, again, there's so many, you wouldn't want to count them. You could say these y coordinates are greater than or equal to -5. And so when there's a lot of answers, like there's infinitely many, you want to describe them instead of actually listing them out because there's too many to list. So your y coordinates will always be greater than or equal to -5. We'll get into that as you get older. That's not a concept I'm going to expect you to do by yourself here. The domain and range here, it varies based on the problem. So this is not discrete because it's not a bunch of dots. So this would be individual specific dots. And then it's not continuous. There's a break. Okay. And so it's harder to describe the domain and range on this one. Again, you'll work on that as you get older. So this would be neither. Okay. Not discrete or continuous. And so it's going to be neither. So let's talk about this. Which of these is continuous, where you could draw the whole graph without picking up your pen? This would be continuous. And which one would be discrete? That'd be this. There's a bunch of distinct points, okay? Not connected. This one here has some connected, some not. This would be neither, okay? It's not continuous for the whole thing. It's not just a set of individual dots. There's some that are connected and some that are not. All right, this one here. This is a word problem, but it's talking about, depending on how many books you purchase, your total cost is going to be less than if you bought them individually. So it looks like the first one, if you just buy one book, it costs you $1.50. If you bought two books, if it was at the same rate, it would be $3 if you bought two. And so they're giving you a discount percentage wise as you get as you buy more books. So 5 books is not the total price. It's not $1.50 each book. It's going to be a total of less than what you would if you just bought them individually. So this would be the independent variable right here. Independent variable. This is the dependent. Okay. And then it says, is this discrete or continuous? This is discrete because they're not connected. And let's go ahead and do the domain. The domain would be 1, 2, 3, 4, and 5. And then the range, you would just list out the Y values. So it'd be 1.5, 2.9, 4.3, 5.7, and 7.10. So just reviewing skills, the domain and range. And then the next one we've got would be 5. Okay. The price of buying a puppy is $400 each. Okay. Graph the function. So the independent variable would be the number of puppies. That's kind of what you choose. Okay. And as a result, the cost. So this is the number of puppies. And this is going to be the cost. Is this discrete condition? Well, let's talk about this. If you buy 1 puppy, how much does it cost? Well, $400. What if you buy 2 puppies? It is going to be $800. If you buy 3 puppies, you notice this. Now, the thing is, a lot of times when you were younger, you connected dots always. It was actually a game you played, connect the dots. The question is, does it make sense to connect these dots? Okay, do the points in between make sense experientially? Would the point 1.5 make sense to put a dot there? And does it make sense to connect all those dots to say, hey, you can buy partial puppies? The answer is no. Okay. Doesn't make sense to connect the thing because you can buy 4 puppies or 5, but you can't buy 5.5. Okay. And so this would be discrete because the numbers in between don't make sense to be connected. And so therefore you're not going to connect it and say it's a continuous, makes sense kind of problem. And the domain would be 1, 2, 3, dot, dot, dot. Okay. And then the range would be 400, 800, etc. Okay. So those would be the domain and range values. What are the independent variables if you're going to buy bulk candy? You know what bulk candy means? It means like there's a bin and you scoop however much you want into the bag, and then they weigh it when you go to checkout and they charge you based on that. And so if you're going to just scoop some candy and it says, oh, it's $7 every pound, we're just going to take some and put it in a bag and they're going to charge you. And so the thing is, you could buy 1 pound, okay? And then as a result, your cost will get more. So if you buy 1 pound, it'll be $7. If you buy 2 pounds, it'll be 14. If you buy 3 pounds, it'll be 21. My question is, could you buy partial pounds? And the answer is, of course you could. And so this would be, the independent would be the number of pounds. And this would be the cost as a result. And then this right here would be continuous because it starts at 0, okay, and it goes up to however much you end up buying, okay? And so, in the point, you can buy partial pounds. So the domain would be basically starting at 0 and then to as big as you want to get, okay? And that's kind of a fancy way to say, but it starts at 0 and goes to infinity. The range would be starts again at 0 and it could go as big as you want as well. And so you could use words to describe it as well, but that's kind of a fancy way to say it's from 0 up to infinity. I'm about showing you some shortcuts if you can grab them. The next one says, what's going on here? Notice there's a connected part and then discrete. It's not overall discrete because there's a connected part as well. So this right here is going to be neither. So notice it increases in cost, and then basically after that point, it's a specific rate. And so the independent variable would be that how many days, and then the dependent would be the cost. Okay. Circadian rhythms. And so a plant has circadian rhythms, and the independent variable would be time. And then the dependent would be the percent of flowers open. Is it discrete, continuous, or neither? This would be continuous, because notice you can draw the whole graph, keep it going. The domain would be from 0 and bigger. And then the range, notice it kind of stays between about 15 and 80. Okay, and so you could say between 15 and 80, or you could say it is between 15 and 80. So that's a fancier way to say it. I have all the numbers in between 15 and 80. So if you mean everything between two numbers, you can actually use those brackets or parentheses. And so including those values means a bracket. The next thing it's going to be, is this linear? Okay, you could graph it and say, does it make a straight line? But you could also do the slope. So the slope is the change in y. So y2 minus y1 over x2 minus x1. So you have to see, what's it changing? This is going plus 26. And then it goes, let's see. I think I figured this over here. Plus 26, and this is plus 18. That does not appear. And this is up a half. And this is up another half. No, it's not a consistent change of y's and x's together. Okay, this one here, this one adds 12, and this one adds 4, and this one adds 3, and this one adds 1. So notice you get 12 over 4, then you get 3 over 1. Those are the same number. Those are both 3. And this would be 6 over 2. Well, 6 over 2 is going to also be 3. So this is linear. And so the rate of change equals 3. Okay, so you have to say, what is happening? Are you adding the same number? So the change of y, so that's the change of this part right here, over the change of x. And do you get the same answer? So let's check this one. This one says I plus 7. This one I plus 1. I plus not, I still plus 1, but no, this is different. So this would be not linear, because it doesn't have the same rate of change from change of y over change of x. All right, well, we are done. Thank you so much. Have a good day.